Today's lesson's about classifying triangles and finding the measure of their angles. So you've already done a lot of these classifications before, so that shouldn't be very hard. A few quick words, though, that you got to be familiar with. First off is triangle. How do we define triangle? Yep. Three-sided polygon. That's simple. Three-sided polygon. Typically, they look like this out to the side. This corner, we name it a vertex. The corners are called vertices. A single one is a vertex. Along with our vertices, our three vertices, we have three sides. So these longer segments are the sides. So we have vertices, a vertex, sides. Those are words you need to be familiar with. We also have three interior angles. So I'll note them with different angle marks. So this one I'm putting 1 angle mark. This one I'm doing 2. This one I'm doing 3. I'm making them different because I don't know how big the angles are. I just know I drew them and they are not all congruent. So I drew them with different angle marks. But we can also have exterior angles, and this is where people get tripped up a little bit. Whenever you're drawing an exterior angle, obviously exterior means outside of the triangle, but here's how you should draw it. You take one side and you extend it. You've now created an exterior angle. It's not the 180 piece. It's the other one. I'll put a little dot. It's this one right here. This is an exterior angle. You can have exterior angles on every vertex. I could have done one over here as well. How would I do that? I'd take a side and I'd extend it. Is it the 180 part? Nope, it's the other part. That's another exterior angle. I could also do this one up here, and it's that one right there. I have three exterior angles. Common mistake, I'll draw it over here to the side. They'll do this in the book. They'll draw a triangle, and they'll draw this. And they'll say, find an exterior angle, and somebody will do this one. Why is that one not an exterior angle? Okay, well, the first thing is we've extended two lines, which we don't normally like. The other thing is that's actually vertical to the interior. That's the same as the interior, so that's definitely not an interior. But a neat thing is this. These two angles right here are both exterior angles. We only need one of them, though. So just focus on one at a time. That one right there would be an exterior angle. That would be good for you. One other relationship to pay attention to is this. If you compare the exterior angle, so this one right here, I'll make it in green. If you compare this exterior angle and this interior angle beside it, what do you notice about the relationship of those two? Those are a linear pair. So the interior one plus the exterior one, they are a linear pair, so we know they're supplementary, meaning they add 180 degrees. That's a good thing to remember. Please remember that. The last little term we got to do is corollary. And basically what happens is if you have a theorem and you just modify it a little, we call it a corollary. So a corollary is a modified form of another theorem. So it's a modified theorem. And we'll see some examples of those today. Next up, we have classifying triangles. This is stuff from elementary school, so you better know this already. If you don't, get it today. A scalene triangle has how many congruent sides? 0. So none of those sides are congruent. Here's the marks that would look like that. So a 1 mark, a 2 congruent mark, and a 3 congruent mark. Isosceles has how many congruent sides? 2. And it says at least. So that means that when it has 3, that's also a type of isosceles. It's just not as specific as we need. That's why we have equilateral. Equilateral is when they're all equal sides. So we have 3 congruent sides. Key thing, if you're breaking this word down, it tells you what it's talking about. Equal lateral means sides. Equal sides. Please make sure you remember that. So that's all classifying by sides. So if I say just classify by sides, you would say one of those words. A lot of times, though, I'm going to come through here and say classify by angles, too. So we have 4 words over here, and you should be familiar with these. An acute triangle has 3 acute angles. What's acute mean? Less than 90. Good. So you might want to write that out to the side. That's less than 90. Less than 90 degrees. 3 of them that are less than 90. A right triangle will have 1 right angle. I think that one's the easiest. We're going to be doing a lot with right triangles this year. Obtuse has 1 obtuse angle. Equiangular, hey, it's very similar to that equilateral one. Equal angles. Equal angles. You can break down the word and figure out what it means. So it has 3 congruent angles. What I want you to pay attention to is this, and you might want to circle these. If it's equilateral, it's also equiangular. These words always go together. If you say one, you have to say the other. If it has equal sides, then it must have equal angles. All right, example 1's decent. It says, classify the triangular shape of the shuffleboard scoring area by its sides and by its angles. So here's the shape it's talking about, and we want to classify by its sides and its angles. Let's do the sides first. So classifying by sides, look at its sides, what would you call it? Well, it has 2 congruent sides, so it would be isosceles. Oops. And by its angles. So look at those angles. Is it a right triangle? No right angles. Does it have any obtuse? Are they all equal? Are they all acute? They're all acute. So it's an isosceles acute triangle. Go down and try this checkpoint. This says draw an isosceles right. So there's 1 triangle. And then draw an obtuse scalene. Isosceles right and then acute scalene. Try that out. All right, here's what I came up with. For isosceles right, I have to have 2 congruent sides and then a right angle. So that definitely works. For an obtuse scalene, I started with my obtuse angle. And then I made sure that all the sides were different lengths, and I marked them. That's key, to make sure you mark your sides with different marks. That way you're proving that they are different. So please make sure to have those marks on the edges. All right, example 2. This is the one that people miss on the test because a lot of you are not really good with the Pythagorean theorem and or distance formula. I would put a star by this one. This is the one that will be on the test, guaranteed. You've got to be able to do this one. When a shape is on a graph, you've got to be able to do Pythagorean theorem and or distance formula. So we're going to have some options here. Now, it just says classify, then determine if it's a right triangle. So there's really 2 parts. Step 1 is classify. Step 2 is it a right triangle? So 2 parts. On my test, I will say explain and or prove. So you can't just look at it and give me an answer. That won't be sufficient. You actually have to show me the math that proves what kind of shape it is. So the first part, they advise using the distance formula. You can use the distance formula to find the length of each side. But we've also done another method. Whenever something is graphed, we can actually do the Pythagorean theorem. So we have 2 options. Do I want to do Pythagorean theorem or distance formula? Hands up for Pythagorean. Hands up for distance. Okay, it looks like Pythagorean wins. We'll do distance on a future one. Actually, I'll just do one distant one here, and then I'll do Pythagorean. Let's do one distance one. I'll do the short one. So from here to here, I'll do the distance formula for that piece. It already tells me the ordered pairs to use, so that's easy. I just need to label them correctly. So I'll always do x followed by y, x followed by y. But they have little sub numbers in the formula, so I got to label x1, y1 for the first point and x2, y2 for the second. So now I can plug them in my formula. What goes first? x2. My x2 is 5. That has parentheses around it, then subtract, and then I plug in my x1, which is 3. I go over to the second part. We start with our y's now. Our y2 is 2. I write down my subtract, and then what do I write? -1, and we know whenever we subtract a negative, that simplifies nicely. Now they go ahead and they say, give me an answer. You can type that straight in the calculator if you're good. If you're not good though, I would show the work. So 5 minus 3 I know is 2. And then 2 plus 1 is 3. 2 squared is 4. 3 squared is 9. Make sure to bring down your radical each time. That's a common mistake I see from you guys. 4 plus 9 is 13. Type in square root of 13 on your calculator. So on this one, it doesn't say how to round, so you got to use your best judgment. When in doubt, I would give 3 decimal places. So I would say it's approximately 3.605. I like to give 3 decimal places. It's usually accurate enough for any type of answer out there. Also, we did ST, not RT. So I'll just switch these real quick. ST, and then later on we'll do RT. So I just labeled it wrong. All right, that's the distance formula. Everybody needs to be able to do that in case you don't have a graph. But when you do have a graph, I like to use Pythagorean theorem. I'll do this one in a different color. I'll work on this segment right here, this green one, RT. If I want to use Pythagorean theorem for that, I've got to remember that I'm traveling from point to point, and I can only travel along the grid. Which point should I start off with? Leftmost is usually what I advise. So if I want to travel from R to T, do I go up or down? And then I need to go to the right. There's the right triangle that I need to use for Pythagorean theorem. So really, it looks like this. And how long is this piece? Count the blocks. 4. 1, 2, 3, 4, 5, 6. And this is the unknown piece that we're trying to find. When we're using Pythagorean theorem, we always spell cab. This is the good formula we like to use. Don't forget c squared equals a squared plus b squared. What piece always goes in for C? The longest piece always goes in for C. And in this case, it's our unknown. So we'll call it X. The other pieces are 4 and 6, so we can plug those in as well. And a lot of this you should be able to do in your head. 4 squared is 16. 6 squared is 36. 16 plus 36 is 52. And some people do some silly stuff here. What do you do at the end? Square root to get rid of the square. When you do that, you should get about 7.211. That's good. So this was the length for RT. So at the end, I could change it back and just say RT is approximately 7.211. Over here, we had the length for TS, or ST, and that was 3.605. I have 2 of the lengths now. I can tell that they're not the same. I'll pause for a second and let you all do the third piece however you want. We're going to do RS. Try the third piece. Do it however you want. Go ahead. So a lot of you did distance and a lot of you did Pythagorean theorem. I'll do each of them, but kind of fast. So please keep up. For Pythagorean theorem, that's my favorite method when I have a graph. I'm going to be doing this piece. I made it red this time. If I'm going to travel from R to S, I usually go left or right. Do I go up or down? Well, truthfully, I don't like to draw inside the shape, so I would just do this. I would keep it outside of the shape. And so now it looks like this. I'll exaggerate a little. There's the right triangle. How long is this piece? 1. And this is 8, I think. And then we'll call that X. So now I can set up my formula. I'll draw it down here. So it's always c squared equals a squared plus b squared. You have to do cab. We're grown up. We'd like to drive. We go in cars. We don't do ABCs anymore. ABC is the old way for Pythagorean theorem. We don't do that anymore. What piece always goes in for C? The longest. What's the longest? X. And then we have our 8 squared and our 1 squared. So 64 plus 1, that's 65. And square root of 65 would get us our final answer, 8.062. There's Pythagorean theorem. Pretty short, pretty quick. I don't usually have sign problems when I do this method. I see a lot of sign problems when I see people do the distance formula, like over here. So we'll test that out real quick. Here are our 2 points. They're right here. I'll label them x1, y1, x2, y2. I'm going to plug those in my formula. First off in my formula, and it's right here again, I have parentheses under my square root. My x2 is 5 minus negative 3. You always put down a minus, then you write down the next number. So I put down a minus, then I wrote down our x1. Plus in between, and now I do my y. So that is 2, bring down a minus, then write the other term, 3. And square that at the end. 5 minus negative 3 is 5 plus 3. 2 minus 3 is negative 1. I'm going to keep parentheses around that. Bring down my radical on every single step. Make sure your paper has that. 8 squared is 64. What's negative 1 squared? Positive 1. That's where I see sign mistakes, right there. People will put negative 1 right there. That would never be good. Anytime you square a number, you're going to get positives. Then I get square root of 65. Final answer is that 8.062. There should be some similarities. You see 8 and kind of a 1 right there. We see 8 and 1. 64 and 1. Hey, we see that over here. 64 and 1. 65, square root of 65. So they are very similar. The distance formula actually comes from the Pythagorean theorem. They're very similar. That's why they give you the same answer. So that's why I don't care which method you pick. Whatever works for you is the best. That's a good problem, definitely on the test. All right, some really important theorems now. You got to get these, and you have to study and know these. Please make sure you study these. This first one is probably one of the most important theorems of the whole book. It says the sum of the measures of the interior angles of a triangle is a special number. It's called 180. Anytime you're looking at the angles inside a triangle, when you add them up, you find their sum is 180 degrees every single time. You have to memorize that. But now here's a little tricky one. It's the exterior angle theorem. So it's talking about to find this angle 1 out here, you have to add two angles together. And it's actually adding these two that are far away from it on the inside. So angle A plus angle B will give me the value for angle 1. In words, here it is. The measure of an exterior angle of a triangle is equal to the sum of the measure of the two, non-adjacent interior angles. Why did I say non-adjacent? What's non-adjacent mean? What's adjacent mean? Not right beside it. So this one is right beside it. I don't want that one. Definitely don't want that one. Unless I'm given that, I can find the one right next to it. But most of the time you won't be given this one when you're trying to find angle 1. So the key is, the ones that are far away from it on the inside will add to angle 1. Here's what it looks like. I'll draw it over here to the side. If this one is 60 and this one is 50, how can I find this angle? Well, it's pretty easy. That unknown one is these two added together. Done. That's how it's used, short and quick. Let's apply that to example 3. So we have our picture down here, and you can apply which one of these two theorems to this problem. Is this the interior angle one or the exterior angle one? Exterior. How'd you know it's exterior? Well, it has an exterior angle. So it's definitely not going to be this interior one. So I'm going to be using this one. And I can see that this little piece looks very similar to what I have right here. So you got to remember this setup over here on the left, or the little formula. The one that is outside, we call that the exterior. So the exterior one is 3x minus 9. That equals two of them added together. Which two do I add together? 73 plus x. So if I add these two on the inside, non-adjacent ones, I get this one. So now I just have some algebra to solve. When we're solving this algebra, what's our first step? First step is what? Move x's first. Which x do I move? Move the smaller x first. Which one's the smaller one? All right, this single x, the 1x. How do I get rid of it? I minus 1x. That way it's gone. I'm left with 2x minus 9 equals 73. Now it's a two-step equation. What step do I do now? There we go. Add 9. So I'm left with 2x, that canceled, equals 73 plus 9 is 82. Last step, usually everybody's good at. Divide by 2 and you get x is 41. Does that answer the question? Use the diagram at the right to find the measure of the angle DCB. Does that answer the question? Does it say find the value of x? No, it says a little bit more than that. I got to use this value of x to find the measure of angle DCB. Well, here's DCB. DCB. I want this one right here. So what do I need to do? Plug it in. Take this value of x, which is 41, and plug it in right there. So 3 times 41, then minus 9. So I'll need a little bit of help. Calculator. All right, so we get 114. So make sure you're writing your answer right. So out here, I would say little m, meaning measure, of angle DCB is 114. That would be a good answer right there. My work is shown out here to the left. I can see where I've substituted the value and I have my final answer. Usually I circle my final answer too. So that would be a good thing to practice. Circle that final answer. All right, here we go. We're going to go to example 4 now. This one says the front face of a wheelchair ramp shown forms a right triangle. The measure of one acute angle in the triangle is 8 times the measure of the other. Find the measure of each acute angle. So it really helps us out. It tells us and it shows the picture that we have to envision. Normally, none of this stuff below the red line will be shown. So you have to understand what it's saying. It says the measure of one acute angle is 8 times the measure of the other. So if I call one of them x, the other is 8 times that value. That's why it's 8x. That's how they got this picture right here. But you have to be able to read and understand that from the picture. You have to understand that it's talking about the 2 acute angles. You have to understand that one of them is unknown, the other is 8 times the value of the unknown. Now, what did we learn earlier about the inside angles of a right triangle? They add up to 180. So that means if I do blank plus blank plus blank, I get 180. I need my 3 angles to go in here. So what do I want to put here? 8x. What about here? And what's the third one? 90. This isn't very hard. How do I solve this one? Yeah, so 8x plus x is 9x plus 90. I already heard it. Subtract 90 from each side. 9x equals 90. Divide by 9. X is 10. Does that answer the question? Okay, the question says find the measure of each acute angle. Does this answer the question? No, this is only one of the values. So I got to plug it in both places. So this one right here is going to be just 10. And this one up here is 8 times that value. So 8 times 10 is 80. Those are my 2 values, 80 and 10. All right, try out checkpoint 3 right now. Try out checkpoint 3. All right, here's the efficient solution. You are supposed to remember that the exterior angle equals what? Does not equal 180. This one does not equal 180. No way, no way. It equals the 2 non-adjacent ones added together. Well, which one are the 2 non-adjacent ones? They're over here. These are the 2 I need to add together to get that. So that's what I write out to the side. And now I solve. What's my first step? Get the x's together, so I subtract 2x from each side. It's gone. I'm left with 1x plus 16 equals 52. Subtract 16 from each side, and I get x is. Find the measure of angle 1 now. How do I use this to find angle 1? Okay, so plug in 36 right here. So I have 3 times 36 plus 16. And I get what? 124. So that angle is 124. How do I use that to find angle 1? 180 minus 124 gives me angle 1. Angle 1, measure of angle 1 is how big? 56. That's the efficient way. That's the efficient way.